10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hello everyone, hope you all are doing well at your end. Welcome to day one of pre-hackathon speaker session. Hack this fall will be hosting live workshops, talks and discussion which has been started from today and will end on 30th October. You can check out our website for complete schedule. Now, coming on the speaker session. In this talk, you will get to know more about how you can use Git and GitHub for almost everything you do on your computer. And with that being said, let me introduce you to all for our speaker of the day. We have Aanisha Mishra joining us. Aanisha is an engineer at Cisco, developing a Terraform providing using GoLang. She is encouraged open source apart from hanging out IDEs. She also nurture her hobbies of traveling, cooking, and writing vlogs. We welcome you, Aanisha, and looking forward for your talk.
Good evening and welcome to this session titled Horizons of GitHub. I am Aanisha Mishra, engineer at Cisco Systems, available on Twitter, LinkedIn, and GitHub, and I go with the same name at all the places. I'm currently developing a Terraform provider for Cisco's data center management tool named Intersight. In this session, first we shall discuss briefly about version control systems, mainly Git. Second, we shall understand what GitHub is and explore the platform. Here I shall show you how and why you should use GitHub for almost everything pertaining to your journey as a developer. This will be a 30-minute session, including 10 minutes of question and answer. Please utilize the chat window in YouTube to post your questions. I shall try to address them by the end. Without further ado, let's embark. Version control systems. The first question that we shall address here is, what is version control systems or VCS? It is a set of tools that help you to track the modifications that you made to the file or set of files that these tools are asked to watch upon. Let's look at an analogy. You all know the story of Hansel and Gretel. The brother and the sister travel from their home to forest and mark their path using breadcrumbs. For us, Hansel and Gretel are the developers. The forest is their end goal. That is the expectation on how an application should look like. The breadcrumbs that they laid out are the checkpoints that will help them to come back to a later state if something goes wrong in their path ahead. The bread from which they were breaking those crumbs is the version control system. The most commonly used VCS is Git. Mercurial and Apache Subversion, famously known as SVN, are the other VCS available in the market. However, Git is prominently used by developers due to its ease of use and extensive features. Git allows you to maintain checkpoints known as commits, also allows you to add messages to those checkpoints, and lets you come back and revert your code to a state that is required in your past. Moving on, these are some of the commonly used Git commands. First one is git init. Initializes the Git using a repository inside a repository. Now, what is a repository? Repository is the main directory or folder of your application. The next one is git add filing. Git asks Git to start watching for changes in this particular file. There are other variations of this command like double dash A in place of file name will actually add all the files and folders in the correct directory into Git. The next one is git commit. Adds a checkpoint with a timestamp and a message. Git status presents status of the repository as to what is going on. Git log presents all the commits made, and the latest one is the top one in the list. Now let's address this question as what is GitHub? Well, GitHub is an American multinational company. This is a definition that you might not hear frequently. Rather, it's usually explained as a platform that allows you to host the software development and the version controls that you have maintained using it in your local system. Now, Git is completely a terminal-based tool. All the checkpoints that you have created for your application are stored in your system. Suppose in an irreversible scenario where the system crashes, your hard work will be in vain. To be prepared from beforehand for such a scenario, GitHub allows you to maintain all your work at their platform free of cost. It's a beautiful and clean UI and very user friendly. Next, let's move to GitHub Dashboard. The URL for GitHub Dashboard is github.com. When I go here, it will ask me to sign in or sign up. There are two options here. You can use this particular form to create a new account at GitHub. Since I already have an account, I will use my account. Here I enter my username and email address and password. There
Excuse
is
me,
an
ma'am.
yes.
Ma'am, actually your screen is not visible. Can you please share it again?
Is
Yeah,
it
now
visible now?
we can, yeah, now we can see. Thank you.
Okay, so I will reiterate here. This is how the launch page of GitHub looks like, and the URL is github.com. There is a form right here using which you can create a new account. There are only three fields that you need to fill, that is username, email, and password. Now, username will be a name without any space, and that has to be unique throughout GitHub. That means there should not be any other person using the same username. Since I already have an account, I will sign in. I'll use my email address or username and password. There is an additional layer of security in between, that is two-factor authentication. This is an optional addition. I have it because I am working in some organizations that mandate this part. I'll enter my verification code here. So this is how the page looks once I log in. On the left hand side, there are list of repositories here along with the teams of which I am a part of. In between is a timeline similar to what we see on Twitter or Facebook. Here I have all the activities that are being performed by the people whom I follow. And the rightmost side is actually a heads up by GitHub. Here they show all the upcoming events, news, and as well as some recommendations for repositories. Since I work on Terraform, I'll take this liberty of showing you what a repository looks like. We'll navigate to HashiCorp's Terraform. All the code of the application named Terraform actually sits here. You can see everything here, and below, if you scroll down, you will see a file that is named readme.md. This is one of the features of GitHub, that if there is a file named readme.md that is markdown, or readme.rst that is restructured text, GitHub picks that and actually parses that and shows below the source code, which works as a documentation for this project. Here you can see the description of the project, and it's a long one. It also involves details about the license. Let's go to each tab here. Here we see HashiCorp. HashiCorp is actually the username for that particular user who has a repository with the name Terraform. The first tab is code, which holds the code for the application. This has many directories, and navigating to one of the directories, we will see there are many nested directories as well as files. Suppose we go on operation underscore types.go, which seems to be a Go file. Looking at the extension, here I can see the code. If I click on raw, I'll open it a new tab. I can see the raw code, like literally raw, as if you have written it in Notepad. And there is another button just beside it, that is play. This is a very useful button when you are working within a team. What it does, it shows which line was added by which user. So if your team consists of around 1,000 members and they are working on the same repository, this particular things makes it very easy to pinpoint that particular person who is responsible for breaking the entire application. Moving back here, let's move to the next tab, that is issues. Issues is actually the start of an action. This is how I would like to put forward. Suppose your application has some issues. You developed it, I was using it, and I realized that if I press Control S, it's actually crashing. So I'll raise an issue here saying that Control S is breaking the issue. Let's dive into one of the issues here. There is a template to most of the issues, like a heavily used repository like Terraform have a template assigned to it where you have to mention the Terraform version that you were using, what was the use case at which the application broke, and what is the attempted solution that you tried, and what is the proposal. Now this is a template that Terraform has defined. If you want, you can have a template, or you can, if you wish you don't want to add a template, it's completely up to you. This is how issue is created. Then labels are added. Now we will go back to issue and I'll show you what all levels are there. There is enhancement, new, bug. So what is the use of labels is, suppose I want to resolve a bug for Terraform. I want to contribute to this repository. I can click on this particular label. What happens is a filter is added and all the issues with the label bug will be shown here. Now, there are other labels as well waiting for reproduce, CLI, version 0.12. This particularly means that there was an issue in version 0.12. If you want to fix it, you can go ahead, click on particular label. All the issues with related to this particular label will be displayed here. So this is mainly for a person who is not a contributor to this repository and want to start a discussion on that particular application. Now, before going to pull request, I'll go back to tab and show you one more thing. That is this particular section. That is, here you can see master. There is a symbol beside that which actually denotes branches. Now, this is a very important feature of Git, that it allows you to create branches. Now, what is branches? Master, beside that you can see there is a small label default. So what is master is, it is the main code of your application, and presumably it will not break. Like we assume that, okay, this is the most stable version. Now if I want to add certain code or add a new feature, what I'll do is that feature might break the application. So rather than committing to master, I'll create a new branch, try out my code there, and if things go well, I will create a pull request. Pull request is I'm requesting that please add my code to the master. Now the concerned people for this particular repository, say the contributors or code reviewers, will go through the changes, will go through your commits, your messages, and then if they find it relevant, they will allow you to merge the changes that you have made to your branch to master. Here we can see we are currently on the master branch. That is why there is a tick there. There are other branches as well here. Suppose we go to a different branch. Here we see the description of this particular branch. This branch is 2 commits ahead, meaning it has 2 commits that are not there in master branch. However, this is 1336 commits behind master, meaning master had some changes from other branches that are not there in this particular branch. Here you have an option to create pull request. If I click on this, here you see it will ask that I'll merge my branch to the base branch, that is master. Currently it's showing cannot automatically be merged because there is a huge gap between master and this particular branch. So this is how a pull request looks like. Here I can write my comments that I added feature 1, I added feature 2, and then I can click on create pull request. Since this is not my branch, I'll not be creating a pull request right now. Going back to this branches section, there are other things that are really helpful here. Here we have a commit ID. Whenever you make a commit, it has to be unique throughout the repository and a hash number or key is attached to the commit. So using this particular ID, you can actually move back in time or actually move ahead also. Suppose you went back to say 2 commits back, changed the message there and then came back to the original one. So all these transitions between commits can be made using the commit ID. It also shows that this particular commit was made 3 days ago, and a total of 27,000 commits were made on this particular repository on this branch, which also includes the commits that were made in master at the point when this particular branch was created. Currently we are in master, so it's showing that master has 27,000 commits. Now we can move on pull request. The concept of branches was important to know before we move to pull request. Here you will see that people have made changes to a particular branch and now they are asking to merge those changes to master. Here you can see UpoDroid wants to merge 2 commits into HashiCorp master from his particular branch. Now this is the conversation, like what are the commits you have made, what are the new features. This is a commit message and a long discussion can go on here. Suppose the contributor did not like the changes that this particular person has made, he can add comments here. If I feel that okay, the changes that he has made is not correct, even I can write my comments here, say hello, great job, and comment. Now, why is it important to comment in an issue is like in repositories that are heavily used, it actually brings you into the radar of the contributors. These contributors, when they are looking for someone to hire into their company who is experienced in languages that they have been using in this repository, which seems to be GoLang, then they might reach out to you that okay, you know how to work around GitHub, you know what is open source, and you seem to be enthusiastic about the same since you were commenting on issues, working around issues, creating pull requests. So it actually adds a lot of value to your portfolio if you create a presence in this open source community. Now there are other tabs as mentioned above, merge 2 commits. We can see what commits this particular person has made. Okay, he made the latest commit 21 hours ago and the message was added service account personation. This is the commit ID for that particular commit. There are checks that are made till now, and if we go to file change, oh my, it seems that he has changed around 4,357 files here. Here, suppose I am a reviewer, I can go through the changes that he has made and review the changes and mark them accordingly. I can either approve or say, okay, I need changes here. So these are the tabs. Next, moving on to actions. Now, what are actions? Suppose I have a project and I want to build it. I can build it in my local system, but how to do it on GitHub? On GitHub, I can add a YAML file which the GitHub will understand and create a setup, say in Docker container. I say that, okay, run on Ubuntu latest. It will create a Docker for Ubuntu and clone my repository there and run the commands that I tell them. Once it's run and the entire build is run successfully, means my code is working fine. So this is a help for the collaborators and code reviewers in a way that suppose I make any change and the action failed, meaning that my code is not compatible right now. There are more changes that has to be done. So what this is kind of a check that okay, I can't merge this branch right now. I have to make changes. Once this action is successfully complete, I'm like okay, at least the build is passing. Later on, we can check that whether this feature is actually fulfilling the purpose or not. I will move back to my profile to show you an example of how the workflow YAML looks. This is one of the repositories that I have been working on. All the workflows are inside this particular folder, that is .github/workflows. In this, there are two YAML files. One is go, one is release, meaning I have two workflows running for this particular repository. Let's go to the first one, that is code YAML. Now, YAML is a file format which is very similar to JSON. Just remove those curly braces from JSON, otherwise it looks the same, and we don't use the double quotes also. Now, this is also a key value pair system. Now, name is go. The workflow is named go. When this will be triggered? It will be triggered whenever there is a push. Now, what is push? I make a code change. Now, I push it to GitHub. I do a commit on Git. Now, I push it to cloud, that is GitHub. I do a push. That command is git push. After git add, we do git commit, then git push. Now, what are the jobs here? The first one is build. Where to build? Runs on Ubuntu latest. Now we'll see how all these are working. Who will read this runs on? So this is a feature that GitHub has provided us that we can trigger workflows. It understands this YAML and does the operations accordingly. So we just have to learn these particular keywords. There are some reserved keywords using which we can write this YAML file and be on with it. The first one is runs on Ubuntu latest. What are the steps that has to be done inside this Ubuntu? First, check out the repository. Okay. Now run the custom command. What to do? This is a particular action which actually installs GoLang in the server. Since my project is in GoLang, I need GoLang to build my project. So I will install Go into my container and then run a make build. Once make build is successful, what to do? Put the exe into .build file. This is the path that I've mentioned, that is .build. Inside .build, it will push the exes. Now let's see what this action does. If I go to this action tab, I can see that there are two workflows here, as I had shown you earlier. One is release.yaml and one was go.yaml, through which we went right now. If I go to Go, here I see that okay, there were so many times this particular this particular workflow was actually triggered. Okay, let's go to the workflow file. This is it. The first step was build. Let's go here. Okay, this is the same thing that we saw here in the YAML file. First, it set up job, then it clones GoLang, and then checks out the code in this particular repository. Then it runs my custom command, archives the provider, and finally completes the job. If all of these steps are passed, means my code was properly working and the build did not fail. All the logs that I see here, it actually helps. Suppose this workflow fails, I'll be able to pinpoint that okay, due to this particular reason, the build failed. Now I can go back and work on it. So moving on to the next tabs, that is projects. Projects is like the parent of all the repositories. You can create your projects here. There are no projects here. So you can see all the documentation here, right? What projects are, what you can do. So that is why I say that it has a beautiful and clean UI. Moving on, Wiki. Wiki is an alternative to writing documentation. People do not mostly use this because they heavily use README file, which is used as a documentation. It is easier to go through that because it's just below the code. I don't have to switch between tabs. Security will hold all the security policies that are implemented here. For our application, we are using API signing, which is to be done by the contributors of this particular repository. So all these details can be included into security. Moving on to the next one is insights. Here it shows me how many active pull requests are there, how many issues are there, what is the traffic. So this was the traffic in the past few days. You can have a look, or commit, or code frequency. So this is kind of an analytics tab for your repository. You can go through this, analyze that, okay, who are the major contributors, who are contributing a lot, what is the code frequency, what is the dependency frequency. Now there is a new term here, that is forks. What is forks? Forks is like, I am borrowing the code from you. Like we have one fork, meaning suppose you want to add to this repository. Now you cannot directly create a branch since you are not a contributor. What you will do is you will fork this, meaning you will take the entire application, put it inside your profile, make changes there, and then create a pull request. That is what is fork. Now what is watch here? Now you want to know what are the changes that are being done in this particular repository. So you can subscribe to this, subscribe for updates for this particular repository. Star is like bookmarking. You can bookmark this repository and come back later on. So these are some of the features of GitHub. There are other platforms like GitHub, like Bitbucket, which supports Git and Mercurial. You can try those as well. But I basically like GitHub, and you can see why. It has so many features and it sits above Git. Now, I'll quickly show you how to create a new repository for your purpose in Hackathon. You can go to this plus sign just beside your profile, click on new repository. I'll select the owner since I'm associated with many organizations and this project is something personal to me. I'll use my username, and here I will give a name to this, that is demo project. Okay, now it will show me that demo project is available because the repository name inside my ownership should be unique. Description is optional. I'll write demo project here. I can make it public. Anyone can see this without even logging into GitHub. If I make it private, only I can see it, plus the people with whom I want to share it. For now, I will keep it as public. I want to add documentation. Yes, I will add a README file. What is get ignore file? Get ignore file. Inside this, you can add the file name or folder name of those files or folders which you don't want to track. For example, you have a Python project. When you run it, there are cache files that are generated, or a cache folder, that is PyCache, is generated. We don't want to commit it because every time we run it, that particular folder will show that there are changes because of a new timestamp that is attached to it. So we can add those folders names or files name inside this .getIgnore file. Now there is one more feature that GitHub provides us. Here, it provides me a template of getignore. Suppose I am creating a project in Python, I can select Python here and it will add those default names or folder names inside it by itself. You can even choose a license. There are a list of licenses here. I will not add any license, so I will uncheck this checkbox for now. It shows that this will set master as the default branch. I can change the name of my default branch by going into settings. Here it says that master is the default branch name. You can change it and click on update. It will be applied to all the new repositories that you work on. Next, I'll create a repository. I will see that the first commit is already done. That is initial commit, and it was made just now. Okay. Why this first commit? Because it added the getignore and readme files. Let's see what is there inside getignore. Oh, okay. So these are the list of files that I need to ignore. Most of them are usually cache files or unit test generated files or package files. So this is a really nice thing that GitHub provides. What is inside README? README is actually this particular section. If I open it and click on edit, I will see that this is a markdown file. Hash means if you have used HTML, you can directly write H1 as well. It's easier if you know HTML. Otherwise, Markdown has its own particular syntax and you can use that. Once I do this H1 and go to preview, I see that, okay, I have done the changes. Next, I will commit this change to my branch. For now, I'm in master. It's okay. I'll commit in master. So the message is update readme. I'm like, okay, fine with it. Commit directly to master branch. master branch or create a new branch. This is an option. Nice. Okay, I'll create a new branch. The branch name is code lucidal patch 1. Okay, I'll make it patch 1 only. Propose changes. Let's see what happens. Okay, so here it actually went ahead, created a template for me to make a pull request. It's saying that, okay, I'm able to merge it, means there are no conflicts. Update readme. Here I can say that updated readme from MD to HTML. Okay, now I will click on create pull request. Voila, my first pull request for this repository is created. It is showing that the first commit that I made was update readme. Coming back to the introduction that was given in the start of this session, that use it for anything and everything. You just have to do git, add, commit, and push. You can even put a doc or PDF file into it. You can commit everything. Why I say this? Because your presence on GitHub is very important when you are actually applying for jobs. People nowadays ask you for LinkedIn and GitHub profile. Looking at your repositories, they will be able to see what all things you have been going through. Here you can see some funny things also. I have a 6 minutes vocabulary repo also, which is private. So I have utilized to this level. I don't create a doc. I don't create a notepad or to-do list. I've added that also into GitHub. I have all the things that I've been running on English. So this is private. Since I've not completed it, that is why I've kept it private. Later on, I'm planning to move it to public. So this is the extent to which you can actually use GitHub. It There are many things that will improve due to this particular usage, your contribution, your communication skills. How communication skills, you will say, you have to express that this is the issue, this is the things that I want to fix. Then you're creating an online presence. So all these will come together in your portfolio, create a wider online presence and make you and increase your visibility. So you can see that I have 51 repositories. Most of them are like this. I have cheat sheets for different languages. There are English cheat sheets as well. There are boot camps, or if I go through a course, if I have to make notes, I try to do them in Markdown because it's much easier. I don't have to increase or decrease the font size by clicking on the A up or A down buttons. Everything is very simple, just like writing an HTML page. So I hope I am able to convey you the message that I actually wanted to do through this session. And moving back to the presentation, I would like to share the further references, since it's not easy to summarize Git and GitHub in just 30 minutes. So these are few links that are completely free. The first one is Git and GitHub for beginners. That is a crash course, and it's a 1 hour video by Free Code Camp. The other two are Udemy courses. One is for 4 hours, another one is 5-day challenge. You can go through this and learn about Git. Once you understand Git, GitHub is very easy. GitHub is the initial place where you can try contributing, like working or adding files. Later on, it's advisable that you move to Git and do all your version controlling stuff using the Git tool. Now it's question answer time. Are there any questions?
Thanks a lot, Anisha. It was a wonderful session and we had a lot to gain. And now we are open for the questions. So uh, we have one question from Tirthak Patel. So he is asking, can you suggest any best resources for GitHub Actions?
There is a documentation of GitHub Actions. I usually ask people to go through documentations. Even Git and GitHub both have their own documentations. If you Google GitHub Actions, it's usually the second link, that is GitHub Actions documentation. There is a quick start cheat sheet as well as learn GitHub Actions thoroughly. That is a very concise way they have described GitHub Actions. Plus, you can go through any of the prominent repositories and go through the workflows that they have created, the YAML files and all. Once you go through the documentation and then try to look at the YAML files, you'll be able to understand what they are actually trying to. Then you move to the Actions tab, where you can actually see what is going on for each particular step. Looking at the logs also will help you that, okay, they created Ubuntu Docker. Okay, they downloaded GoLang and installed it. So this is the step that you can go through: first documentation, then the YAML files of the popular repositories, and I guess you will be a pro in GitHub Actions.
Thanks, Anisha. So there's one question from my side. Like, as you know that we are organizing Hack This Fall hackathon. So there are different levels of hackers are joining us. So do you have any tips or suggestion which you can like to give them, like for the beginners or the person who are already intermediate in this field?
Something I learned recently is there is always something new coming up on GitHub. So maybe subscribe to one of the GitHub news channels. Recently, they came up with a README file, which is actually an introduction to yourself. You can create a new repository with your username and add a README file that will be passed and shown as in the profile page. So these there is a discussion tab that is coming up. So stay updated with that. Plus, open. I'm sure each of us are using open source. So it's time that we start contributing. I recently started contributing, though I've been using GitHub since 3 or 4 years. And I request even the intermediators who are working on GitHub to start contributing. Suppose you are using PySpark or Pandas or NumPy. There are n number of issues there. You can try contributing there, and you might even learn something new about NumPy even after using it for 2 to 3 years. That's all.
These were really good suggestions, and it would be a great help for the hackers. Thanks once again, Anisha, for joining us today. Uh, you,
Thank you. I have already shared the contact details, especially on LinkedIn. You can reach me on LinkedIn. Same name, Aanisha Mishra. Let me know if you have any issues, especially related to Git or GitHub. I'd be happy to help you there. Thank you to the Hack This Fall team, and all the best to the participants and students for this hackathon.
so well, now in the end, I just like to say you that please fill the feedback form, which will be present in the chat box, and after that we will assign like by looking the responses of that form, we will assign you the certificates for this session, and it will be only open for the 15 minutes. So won't so try to fill it as soon as possible. And thanks a lot for joining us today. Don't forget to subscribe our channel so that you can get the update for all the upcoming workshops. Stay tuned. Hope to see you in the next session. Stay safe. Take care.